Hello, my name is Casey Shea from Project Make at Annalene High School, and today we're going to talk about the safety and usage of our 90-watt CO2 laser cutter and engraver. The CO2 laser can cut or engrave on a variety of materials. It can cut cardboard, wood, acrylic. It can engrave on even more materials, glass, marble, the same cardboard, wood, acrylic, actually even food items. We've carved some things on tortillas before. We're going to spend most of our time today just talking about cutting. We're going to use vector graphics. The laser cutter is actually a safe machine to operate. It doesn't require any personal protective equipment, no safety glasses, no gloves, no special gear at all. It's all designed to be safely operated for the operator. However, there are some things about the machine that we need to take care of so we don't cause any harm to the machine. So first, there is a power strip right here that has the air compressor and the water chiller. The water chiller is important for cooling the tube. Big 5-foot long glass tube is behind here. It's well contained in this machine, you can't see it, but if there's not water going through it when it fires, it'll blow the tube. It's about a $1,500 replacement. We don't want to have that. Luckily, there's a switch in here that if the water chiller is not running, that tube won't fire. The air compressor, the feature or the reason for it is it blows a little stream of air in here. As it cuts, actual flames might come up. The air compressor will diffuse the flame and will keep anything from actually flaring up and starting to fire. The door, when it's open, there's a magnetic interlock so that it also cuts the laser from cutting. You cannot stick your hand in here and have anything cut. If you did, you would burn yourself tremendously. There are safety features that cut the laser when it's open. But the main consideration is that because it cuts by burning through the material, it needs to be attended at all times. You cannot walk away from a laser cutting job because if, for a number of reasons, it flares up, catches on fire, you need to be here to be able to deal with it. Okay, so if we do get a fire, it's going to be cutting, you're going to be here watching it, something flares up, you just open up the machine, and usually you can just blow it out. If it doesn't go out just by blowing it out, you can pick up the material and get it out of the machine. Worst case scenario, we've got a fire extinguisher nearby. We don't want to do that if at all possible because it makes a mess and it takes a long time to clean back up the optics and all the machine. So to begin to use the laser cutter, we need to have a digital file, and most of the files that we use we design in a program called Inkscape. The details of getting your file laser ready are covered in a different lesson. But for now, I've got this stencil, this image here of the Project Make logo, and it's in 3 different colors. So the laser cutter controls the speed and power, which controls the intensity of the cut, and you can break down different lines by different colors and have each of these colors perform at a different speed or power. You can control the order and the speed and the power based on the color. So what I've got here is this red circle, green outside of the logo, and the black inside of the logo. I'm going to want to cut the red and cut the black stencil and just engrave the green. So my file is up. I'm going to get that file to this computer either using a Dropbox or a flash drive. We rarely do design on this computer. This is really just to drive the machine. Once I've got the computer up, the file up here on the computer, I'm looking for this blue little triangle button, which is the Retina Engrave software. When I click on that, it fires up the full spectrum driver. And what's interesting about this, the laser cutter, is it just is treated as a printer. So you can really design your content in a variety of programs, even up to something as simple as Microsoft Word, and we just hit print. We've got it set as the default printer for just about everything on this computer. Now in the background is the full spectrum laser. If it is not running, it will not print my document, but I see here that it's on full spectrum Retina Engrave. Come back here now, and I want to make sure that my paper size, my document size, actually matches my image here. Funny things happen if I don't have that, either too big or too small. So luckily I can just do a quick document properties, resize page to content, and then resize to that selection, and the page now has been transformed to fit my document. And if I've got the page settings either if too small, then I might not be able to print things that are outside of the page. If it's too big, it confuses the machine as it tries to find its limits. It's important in Inkscape because there's no limits to the page sizes. You can design billboards or building stuff. So it's a good first step before you try and print. Okay, I got the document size set right. Now I'm going to do a file print. And for small, less than 8.5 by 11 pieces, all I have to do is just hit print. For bigger images, there's a couple other steps to do. We'll go over that in more detail when it's appropriate. For now, it rendered in the background as a raster engrave and as a vector cut. Raster engrave allows you to get some gradations and do engraving with bitmap and like JPEG files, so you can get like photos and do some engraving. Today we're just going to focus on the vector. So we're going to be on the vector tab and our 3 colors transferred over there. You can see that the 3 colors have separated out into 3 different control lines here where we can control the speed, power, order, and the number of passes. So that's my file ready to cut. We got to get the machine ready to cut as well. So the first step is we want to turn on the power switch, which is located down here on the right hand side. Little fan goes on, light goes on, and it starts its little boot up sequence. When it's booted up, it has an IP address because these talk the computer and laser cutter over the Ethernet. It wasn't connected because the machine wasn't on when we first opened the software. So all we have to do is go back here to the reconnect button. It'll search the network, find the right IP address. There are times where we've got more than one laser cutter hooked up in the lab, and we'll have to go over what those procedures are probably in person. But for now, I'm connected, turned on. First thing I want to do is home the laser head by hitting this little home switch up here. And then it takes the head all the way up to the upper right hand side so it can orient itself in terms of the limits of the machine. There's some safety features built into the software to make sure that the file that you're trying to cut won't damage the machine. Next step is going to be to put our material in. For today, I'm just going to use some cardboard. A little piece of cardboard here. And put it, usually the best cutting happens in the upper left-hand side, so I kind of want to center it over there. And when I've got a sheet that's a little bit warped like this, I've got a series of little metal weights that I want to use to keep the piece as level as possible, because the laser lens is optimized for a particular focal length, and if it curves too much, then we start losing some resolution, losing some quality. So once we've got our machine homed and our material in and flat, we need to focus the bed to get at the optimum height. So on the panel here, the arrows drive in the X and Y direction. When I'm in this fast XY is the default screen. I want to move it somewhere about into the middle. The focus gauge right here with the little tab is going to place we're going to place it right up on top of the lens. And we're going to adjust the height of the bed up to reach the bottom of that focal gauge. So right now I can see that it's a little bit low. I need to bring the material up. So what I want to do is go back over to the control panel on the machine, and from the fast XY that it defaulted to, I can go through slow XY, fast Z, slow Z, and test. Slow is, I don't want it to be moving too fast because I just got a little bit of adjustment to make here. So I'm going to bring the bed up. And the arrows, now that I'm in Z mode, up actually moves the bed up and down. Just want to adjust it until I can feel that tab in connection with that little lip on the focus lens. Got it pretty good right there. And focusing is a really important thing to do, important step of the process, not just for the quality of your material, but also to prevent flare-ups. If it's out of focus and the beam's not really combined, you have more of a chance of catching something on fire, especially cardboard like we've got today. Next step is then to set the origin for where we're going to cut. all of the Retina Engrave software actually starts cutting the way we've got it up on the upper left-hand corner. So we can move this back to fast XY. Now that we've got our Z, or depth, adjusted, we won't have to go back to that, but I want to move the head up to the upper left-hand corner. And if I was really worried about like centering something or getting real precise, I could switch it to slow XY so I could get exactly where I want to get it. For this right here, fast XY is probably good enough, but that's the reason for slow XY. So we're, at this point, all lined up and ready to cut. Before we actually cut, we want to run the perimeter to make sure that the image is going to fit on the material that we're going to use. Also, if it were critical to center something on a piece of material, this would be our time that we could fine-tune it. So to run the perimeter, we have to push the button on the machine with the 4 blue arrows and keep an eye on the laser head, and it will show you the amount of material it's going to take. It's the square outline, so it's not necessarily going to be following any of the lines, but that's going to be the amount of material you have to have. The red beam that is showing right here is not the cutting beam, so it's not going to hurt us. It's just a pointer beam to show you where we're going to go. Okay, so we want to set the order and speed for the 3 different colors that we've got. The red we're going to cut on the outline, green is just going to be an engrave, black we're going to cut through to make this like a stencil. In general, we want to do the outside cuts last. So that'll be our red one. We make that order 3. And I will do the interior stuff first. That's the black, so I'll make that order 1. Green is already set as order 2, which is great. So I'm going to cut through the cardboard. I just happen to know that a good setting for cutting through cardboard is a speed of 70 on this machine and a power of 30. There's a chart that we'll go over, and in class we'll be able to talk about specific settings and how we find specific settings, but 70-30 is a good cutting speed and power. For the green engraving line, we can go at full speed and just 1% power. And then the same cutting speed and power for the red line, we're just going to do it after everything else is done. So 70-30. 30. So 1 pass for each of these. Some material takes multiple passes to cut through, thicker material, harder material. We've got the vector mode showing here. The only other things that we have to do before we can press go are to turn on the fan and the air compressor and water chiller and the exhaust fan. So when we've completed cutting, I want to reach in and remove any of the weights that I put on, put them back safely out of the way. Before I move anything too much and change the alignment, I want to make sure that everything cut through in case I have to do another pass. It's a lot easier if I don't move it. I did see that everything dropped down, so I know that I've got my finished project, Project Make Stencil, but I've also got some cleanup to do. So I don't want to get so excited about my finished project that I leave a mess for the next person. So certainly the bigger piece of material, if it's usable, I want to keep it. We can put it with some other usable material, say over here. Some of the little pieces, sometimes even the stuff that's left over is usable, like these letters I could use for something. We happen to have a box of just interesting cutouts. But if not, I want to get them out of the machine. If they're big enough that I can just grab, I can grab them. Otherwise, we've got a little shop vac, and if I cut little tiny things, the last thing I want to do, make sure that I shop vac up all the small pieces. Close everything up, and if you're the last person, if there's not somebody waiting for the laser, we can go ahead and shut it down. Don't walk away leaving it on. But if there's somebody waiting for you, we can leave it on so that it stays homed and is ready for the next person. And here's our finished project. It's just a cardboard trinket, but it could be rendered in some other more permanent material, acrylic or wood, but I think cardboard in itself is pretty cool.